Hello guys, in this video I'm gonna show you how to solve basically a circuit, an AC circuit using the node analysis method. Okay, so in the node analysis method that we learned in with DC circuits will be applied in exactly the same way when we use or when we deal with an AC circuit. When I say an AC circuit, it's a circuit that either have like an AC source, a variable source, like a sinusoidal source, or have basically an inductor or like a capacitor or both. So this is an example that you see on the screen here from the book, our book, basically. And we have here like a capacitor with a reactance of minus J4. We have an inductor with a reactance J4. We have two resistances, 3 ohm and 6 ohms. We have a voltage source and a current source. The voltage source, which is called the VS here, has a 10 volt. And as you see, the angle is 0. So when the angle is 0, we don't write it. We just write, the volt. IS, on the other hand, has a phase, has an angle. So it's a 5 angle 30 degrees. Of course, degrees and radians, matter so much here. Okay, so you must know exactly it's radian or degrees. In our examples, usually use degrees. Okay, good. So I'm gonna solve with this example in that video using the node analysis. And of course, if you solve it with other like methods like Thevenin, for example, mesh, or superposition, you should get the same answer. Okay, so what I'm gonna do, I'm gonna use this example in 4 videos. Okay, in this video, node analysis. Next video, Thevenin. Third video, I'm gonna do superposition. Fourth video, mesh analysis. Okay, 4 videos, same example, exactly the same answer, or maybe like because of the approximation and stuff, it will be very close. Okay, so let's do that. So what is required here? So in this question, the question is to find IA. This current here, IA. Good. Okay, it flows like in that direction. Okay, so in node analysis, we should determine like the nodes in the circuit that has more than 2 branches. Okay, so if we look at our circuit here, we have 2 nodes that have more than 2 branches, 3 or more. Okay, so this guy here, this node here, this has more than 3 branches, actually 4. We have a branch here, a branch here, and this branch, of course, with the current IS, and this branch is a fourth branch with the current IA. Okay, and this is the second node that has also 3 or more branches. Okay, as we learned with the DC circuits, when we learn the node analysis, we should choose one of them and make it ground. Okay, actually, you should ground any circuit you have. Okay, and you should choose any node basically to make a ground. Here we have only 2 nodes, so we should choose one of them. Usually we should choose the one near the bottom for some reason, but it doesn't have to be so. You can even choose the one on the bottom, on the top. It's okay, very okay. Okay, so we're gonna choose this guy. So we're gonna ground, the node on the bottom. And there are 2 like symbols for the ground. Some people use this symbol here, and some people use this one. Both are the same, no difference. Okay, good. Let's also call the node on the top VA, just to match IA. Okay, just to match IA. So in our node analysis, we go to the nodes and write the Kirchhoff current law equation. Okay, so we're gonna apply KCL, Kirchhoff current law, at node VA. Okay. So what Kirchhoff current law says, it says that it's basically the conservation of like the charge. So the amount of charge that flows into the node equal to the amount or the rate of charge that comes out of the node. And rate here is very important word. Rate means the amount of charge coulombs per second, which is current. Okay. Basically, the sum of the input current equal to the sum of the output currents. Okay, that's it. So let's apply this. So let's name them. Okay, so I'm gonna name. So we have already one with the name IA. That's fine. The other one is IS. It's also fine. Let's call this guy like let's call this guy first I2, and this guy is I1. Okay. So what are the currents that going into the node? So currents into going into VA is basically IS, only IS. Okay. Now the currents going out of VA are three. We have I1 going out, we have I2 going out, we have IA going out. All of them are going out. Okay. And by the way, you can choose any direction. I could have chosen like I2 going into the node. It's very fine. Okay. At the end of the day, if it was the other direction, it will be negative. Okay. So like a 5 ampere going in that way is basically minus 5 ampere going in that way. That's it. Okay. Good. Let's do that. So let's write KCL equation here. So IS, which is the current going into the node, should equal to the current output, which is I1 plus I2 plus Mr. IA. Good. Very good. Okay. What is IS? IS is 5 angle 30 equal to. What is I1? I1 is the current flowing from VA to the ground. Okay. So if it's flowing in that way, we assume that this is the positive and this is the negative. Okay, because always the current flowing from positive to the negative of the resistance or any reactance in general. Okay, so when you have a branch like that, if we name this like V1, if we name this V2, and the current flowing in that way, so when this is, for example, R, so I here is equal to V1 minus V2 over R. Okay, the node from which the current is going into the resistance minus the nodes that the current is going to divided by the resistance. Okay, so basically positive, negative, so the positive node minus the negative node over R. Okay, or the reactance, whatever, C. Okay, so I1 will be VA minus 0 because this node is VA, this node here is 0, ground, over R, which is 6 ohms, plus I2, yeah, that's like a little bit tricky. Okay, so we know this node, VA, but we don't need, I'm sorry, something happened here. But we don't know this one. Okay, let's figure this out. So look, we have here a source called VS, the voltage source. What does the voltage source do? The voltage source increase the voltage of the positive node than its negative node by the amount of the battery voltage. Okay, so let's do this on a side. If you have a battery like that, okay, this battery has a voltage called E, and this is the positive node. Let's call it V positive, and this is a negative node. Let's call it V negative. It's just a name. Okay, if you have a situation like that, that means that V positive minus V negative equal to E. If you are confused by the names, let's call it V1 and V2. V1 here, V2. Let's just, hash out this. If you have a situation like that, that means that V1 minus V2 equal to E. Okay? That's it. So, look, this node here short circuit here. This is still ground. It is 0. So that one here is 0. Okay. We don't know this. Let's call it V. So from that one here, V minus 0 equal to Vs. Okay. So basically V equal to Vs. So that node here equal to Vs. Good. Good. So I2 is equal to, I2 is flowing in that way. That means that is the positive, that's the negative. So I2 equal to VA, which is the node from which the current is going from, minus V, which is VS, which is the node that is the current is going to, the negative one, over the resistance or the reactance value. The reactance value here is minus J4. Minus J4. Keep it like that. Don't touch it, you know. Now, IA, what we applied for like I2 and I1, we can also apply for IA. So IA is flowing in these resistances. Okay. So they are resistance on series, you know, so they are like that. Here is IA. 3 ohms, J4. Okay. So it's flowing like that. So this is the positive, this is the. So the negative here is the 0 and the positive is VA. Okay. So go look. So this is IA going from this node VA and flowing until it reach the ground. Okay. So IA is basically VA minus 0 over the whole resistance, 3 plus G4. You can combine any two resistances in series, okay? We're gonna do this a lot. Good. So that's basically the equation at node VA. Let's review it together. You know, first the current is going into, which is IS, 5, and it's given 5 angle 30. This is given in the question here. And it equal to I1 flowing in 6 ohms. So it's equal to the current, the node that is the current flowing from, minus the node that is the current is going to, VA minus 0, because the second one is 0, divided by the resistance. Same for I2. It is VA minus node V over the reactance, which is minus J4. Okay, and finally, IA is VA minus 0 over 3 plus G4. Okay, that's the Kirchhoff current law at node VA. Let's reduce it, okay? Make it nicer. 5 angle 30 equal to. So VA minus 0 is VA, so VA over 6 plus VA minus G4 minus VS minus G4. Okay, just distributed the denominator to the numerator, I'm sorry, plus VA minus 0 is VA, so VA divided by 3 plus G4. Okay, remember, you know VS is 10, it's a given, VS is equal to 10. So that's equal to VA over 6 plus VA over minus G4 minus 10 over minus G4 plus VA over 3 plus G4. I'm gonna bring minus 10 over minus G4 to the left-hand side and keep VA on the right-hand side. So 5 angle 30 plus, because minus 10 over minus G4 will go there with a plus sign. So this sign here will be a plus sign. So 10 we have in the denominator minus G4 equal to, I'm going to take VA as a common factor. So we're going to end up with 1 over 6 plus 1 over minus G4 plus 1 over 3 plus G4. We are almost finished. So VA equal to 10, going to be big. So 5 angle 30 plus 10 minus over minus G4 over 1 over 6 plus 1 over minus G4 plus 1 divided by 3 plus G4. It looks ugly, very ugly. Okay, I know that. No, don't worry, I know that. I feel you. Okay, it looks very ugly. Okay, and we learned it like from week 1 and 2, basically how to like make a division, of complex numbers. But I'm gonna teach you something that makes your life extremely easy. Okay, when you deal with complex numbers. Okay, so basically we're gonna use an online calculator. Okay, and you can just enter this into the calculator with some minor modification, and it will give you the final answer. You don't need to do any simplifications. Okay, but it's easier to work. We know, guys, that there are a polar form and Cartesian form. Okay, so the polar form for any complex number is a angle theta. Okay, and this is the polar form. The Cartesian form is x plus gy. Okay, I'm sorry, y. So this website that I'm going to show you, it's better to use the Cartesian form. Okay, so we have here the polar form 5, or the phasor form 5 angle 30. So we're going to convert that first using the same website I'm going to show you in a moment. Then we go back and enter everything in that like website I'm going to show you. Okay, very easy, and it give you the final answer without any simplification and touching from you. So you have like a good probability of having like accurate final answer. Okay, good. So let's bring up this website. So okay, here it is. Okay, so first, as you see, guys, here is like a division that I did before. So we need first to get like the Cartesian form of the polar form 5 angle 30. Okay, so I'm gonna use another website to get first the Cartesian form, then go back and use this website. Okay, I can do it here also, but it's better to use the other. This is the other website. Of course, I'm gonna leave like the links to this website on the description, so don't worry. So we need 5 angle 30. Okay, so you write here the radius. Okay, the polar form means polar, like a radius, and it goes into like a circle. And here is the angle in degrees. Okay, then we need to convert. So basically, we click here, calculate polar to rectangular form or Cartesian form. It has two names. So 5 angle 30 is basically 4.33 plus 2.5 J. So we go here, I'm sorry, we go here to our example. So I'm gonna write this down. So VA equal to 4.33 plus 2.5 J plus 10 divided by minus G4, same numerator, 1 over 6, 1 over minus G4 plus 1 over 3 plus G4. Very ugly step. But now we're gonna use our like calculator, and we're gonna do it. So let's bring this to the side here, okay, and use this guy here. Yes, this. So let's write this down. And please follow my way, because sometimes this website screwed up, if you write stuff like in certain ways. So use my method here. So we need like numerator and denominator. Okay. So just make a parenthesis for each one. Okay. So this is a parenthesis now for the numerator. Okay. We have 4.33 plus 2.5 I. Yeah, this one. So we use in our circuit analysis for the complex number -1, square root of -1, we use the symbol J. But the general use, or the general, like in math, generally we use the symbol I. And why we don't use I in our like circuit analysis with complex numbers? Because we usually call the current I. Okay, that's why we use J, to differentiate, not to confuse us. Okay, so in all other fields, when you use the complex number, which is square root of -1, we use a letter I or the symbol I. Okay, but in circuit analysis, we use J. Why? Not to confuse with the current. Okay. Okay, so we're gonna use here I in this website. Don't worry. Plus, so we did that one, we did that one. Now we should do this one. This is like a fraction by itself. So again, both are parentheses, not because we don't know, we don't want to have any mistake. Okay, so we have 10 divided by. I also like to use a parenthesis for like the complex number by itself minus 4i. One might say, why you write I4? Sometimes this like website screwed up, and instead of having 4i, okay, it transfer like I4 equal to 4i, basically. It translated as I to the power of 4 for some reason. Like looks like a bug. But anyways, let's use this constant first, then we write I. Actually, this is the convention. Okay. Now the denominator. We have three terms. Okay, so three terms. So let's widen this. So one, two, three parentheses. Okay. And they are all added to each other. So I'm going to add plus, another plus. So the first term is 1 over 6. That's z. Second term is 1 divided by minus g4. So 1 divided by, again, parentheses, and minus 4i. Don't write it I4. It might be translated incorrectly. Okay, that's a disclaimer here. Otherwise, it's a very great website. So the third one is this term here, which is also a fraction. So we're gonna use 1 divided by and open a parenthesis for the denominator, 3 plus 4i or G4. No. Good. Let's review, because the main problem with this, like with these questions or AC circuits in general, is accuracy. Okay, that's the most problematic, like, or it's very error prone. Okay, because you deal with complex numbers, phasor form, rectangular form, or Cartesian form. It's very confusing. Okay, and it's very error prone. Anyways, so let's review. So the numerator here, let's review it one by one. So 4.33, 2.5i plus 10 divided by minus 4j, or 4i, of course, here in this. Yes, okay. Now the denominator, we have three terms, 1 over 6, 1 over minus 4i, and we have 1 over 3 plus 4i. Okay, good. Looks good. Looks good. Okay, let's calculate now. Okay, so VA is that value here. So V, I believe this is the correct answer. But let's check. And you just need like two decimal places. Don't like confuse yourself. And you can make rounding, of course. Okay. So here it's 734. So 4 is less than 5. So keep the 3 as it is. Plus 11.56 was 0j. But remember, we don't need V. We actually need the I. We don't need VA. We need IA. Let's bring this back to full screen. So we don't need VA. The question is actually asking about IA. But what is IA? As we said before, IA is basically the current like flowing here. So it is VA divided by the whole like resistance in that branch. Okay. So IA is equal to VA over the whole resistance of that branch, which is 3 plus G4. 3 plus G4. Very easy again. What you do, you just copy and paste. So let's go back here to that guy. So we're gonna take this result, open a parenthesis. Okay, this is the numerator. What is the denominator? This is VA. The denominator is 3 plus G4. 3 plus 4i. Again, that's a disclaimer. If you write it 4i. If you write it like I4, it might make a problem. Okay. So now we calculate. Oh, yeah, that's the correct answer. So I is equal 4.1, okay, minus 1.61 J. This is the Cartesian form. And also, the good thing about this website, it gives you both the Cartesian or the rectangular form and the polar form or the phasor form. So we have here 4.4 angle minus 21. Then it gives you the angle degrees, minutes, seconds. Okay. So that's basically the degrees. That's called minutes. That's called seconds. We don't like that. So if you go down a little bit in here, yes. You see, if you go down, this happens all the time. It gives you the formula that we need, like the with fraction as a fraction. So minus 21.52 point. I'm sorry, 0.45. I'm sorry, 0.45 degrees, and that's the correct. Okay. So that's basically how to solve in a very easy way, because I may take time because I was explaining, but if you do this by yourself without like teaching anyone, it will be very fast. Okay. The only like the breakthrough here that we learned is that you don't need to do the simplification yourself of the complex number. No, use online calculators. It will make your life so easy, so easy. We learned two websites. The first one I use usually to do like the conversion from polar to Cartesian and or rectangular and vice versa. And the second one is to do the calculations like multiplication of or addition, like division as well. Okay, guys, that was it for this video. Thank you very much for watching and see you in another video. Bye bye.